I'm back today, and we got more Anki cards to go through. Obviously, I'm just trying to think how I want to tackle this. Let me write down what I want to tackle first. Let's get a pen. Oh, here we go. Okay, so I'm gonna start with Biochem, Chapter 2, for sure, and then we'll switch over to Biochem or Bio, Chapter 8. That's on antibodies. And then we'll switch over to maybe Chem Chapter 10. So I have a not good knowledge on that. It was Chapter 3. I think Chapter 3 was on like atom interaction or something. I don't know. And then OChem, gotta do Chapter 5. That one I haven't done in a while. And then for physics, Chapter 2. That should get me caught up. And if I really want to, I can do Biochem, Chapter 3, but that's optional. Okay. So we have a target, we have a plan. And I'll just put it here for now. Okay. Alright, without further ado, let's get started. 410. We'll see how long we go through. Chapter 2. The y-intercept of the Lineweaver-Burke plot gives us 1 over Vmax. Lyases are enzymes that break up one compound into 2 compounds. Holoenzymes. What is a holoenzyme? These are enzymes that are in the same phase as substrate or something? Enzyme with a necessary cofactor. How do enzymes lower the activation energy of this reaction? They stabilize the transition state of the reaction, so they lower the activation energy. What is feed-forward regulation? Where the product of an earlier reaction will stimulate the reactant of a future reaction. Km is a Michaelis constant, and Km equals, I don't remember what Km equals. Michaelis constant, concentration at which half the enzyme's active sites are in use, and the velocity reaction is half of Vmax. Km can be used to compare for percentage or Km 0.5. So Km, Michaelis, is a concentration at which half of the enzyme's active sites are in use. The concentration at which half of the enzyme's active sites are in use, and the velocity reaction is half of Vmax. Vmax is the theoretical maximum velocity for an enzyme because all its active sites are held by or taken up by substrate. So the enzyme is saturated. Microenvironment where the reaction takes place between the substrate and the enzyme and the reactants creates a microenvironment to stabilize the transition in its state. How does the rate of reaction relate to the amount of enzyme in substrate? As you increase the amount of enzyme, you can increase the rate of the reaction. Okay. If you have 10 enzyme molecules in one substrate, there's only one enzyme that's actually so there will be small. So this is basically saying if you have 10 enzymes as you add more enzymes, you can speed up the reaction rate. But if you keep adding more substrate, you'll hit a point where it reaches saturation, where adding more substrate will not affect the speed of the reaction. Negative feedback is where products of the forward reaction is used to regulate the substrate of a previous reaction. A substrate is a molecule that binds to an enzyme active site. Lock-in theory of enzyme activity states that, give me a second here. Lock-in key theory of enzyme activity states that, how should I describe it? Odor molecules, or not odor molecules, lock-in key theory of enzyme. Substrate binds to an enzyme active site, just like a lock in a key, it fits snugly. Hydrolases are things that catalyzes the conversion of one product into two other products by using water. So decondensation reaction. A ligase is something that catalyzes the formation of one compound or two compounds into one compound, typically using ATP. Oxidoreductases are enzymes that catalyze oxidation reduction reactions. Usually have dehydrogenase or reductase in their name. The x-intercept gives us -1 over km. X-intercept gives us -1 over km. But it's heard. Alright, good. Irreversible inhibition. The inhibitions. I totally forgot the inhibitions. Irreversible inhibition. Binding of this inhibitor to an enzyme renders it completely useless. It basically changes the conformation of the enzyme so it can't bind any more substrate. Oh. Covalent bond. Cofactors or coenzymes are organic molecules or minimals or ions that are required for the enzyme to function. Non-protein molecule is required. K-catalysis. Equilibrium constant for a reaction that is being catalyzed by an enzyme. Equilibrium constant for a reaction that is being catalyzed by an enzyme. How does a competitive inhibitor affect Vmax, Km, and Lineweaver-Burke plot? Competitive inhibitor... Oh, man, I totally forgot this. Competitive inhibitor competes with the substrate, which increases the amount of substrate you need to get equal catalysis, which increases Km. Competitive inhibitors compete with the substrate, which increases the amount of substrate you need to get equal catalysis, which increases Km. Competitive competes with substrate. So competitive inhibitor increases Km, but do not affect Vmax. So they have a right shift to x-axis, no change in y-axis. Boom, boom. Competitive inhibitors. Competitive inhibitors. Kmax in Km increase. Km increases. Vmax decrease. Vmax no change. After an enzyme denature, is it possible to cool back down? Sometimes. What is an exergonic reaction? Delta G equals negative and it spits out energy. Hydrolases, ligases, oxidoreductases, transferases, and two more I'm missing. Isomerases and lyase. A little hot. Ligases, isomerases, lyases, hydrolases, oxidoreductases, transferases. It's like a Michaelis-Menten graph of cooperative ends. Sigmoid curve. What is the difference between a coenzyme, cofactor, and a prosthetic group? Prosthetic groups are typically covalently attached, I think. Coenzyme cofactors aren't covalently attached. A prosthetic group is just a cofactor or coenzyme that's very tightly bound to the enzyme and is critical for its function. Transferases transfer functional groups from one molecule to another molecule, typically phosphate groups. Competitive inhibition. Inhibitors compete with the enzyme, or compete with a substrate for the enzyme binding site. Hill's coefficient. Hill's coefficient greater than 1. I forgot which one it was. No cooperative. One ligand increasivity. Cooperative binding. Ligand, no cooperations occurring. Okay. Apo enzymes. I think these are enzymes without their cofactors present. What is enzyme substrate complex? The enzyme plus a substrate in a complex. Okay. No. Enzymes are things that catalyze biological reactions. Catalytic efficiency. Kcat over Km. Catalytic efficiency equals Kcat over Km. Isomerases moves functional groups or moves electrons or bonds around the molecule but doesn't change the arrangement of the atoms themselves. Catalyze the arrangement of bonds. How do enzymes respond to environment? Temperature, pH, and salinity can affect the way they operate. Cooperative enzymes, binding of one ligand increases its affinity for another ligand or vice versa. Saturation is when you add so much substrate to the point where they all bind to the enzyme active site, and adding more substrate will not increase the enzyme's velocity. Lineweaver-Burke plot is a modification of Michaelis-Menten graph where you have 1 over V and 1 over S instead. What is a hollow enzyme? These are hollow enzymes or enzymes with their cofactors. Endergonic reactions absorb energy. Delta G equals positive or negative. No, yeah, delta G equals positive. Adding more enzyme is the only way to increase Vmax. Generally speaking, coenzymes are inorganic in metal ions. Oh. Coenzymes are organic. Cofactors. Okay. How do increase in temperature affect enzyme kinetics? So every 10 degrees Celsius increase starting from 0 will double the enzyme reaction rate until it reaches an optimal temperature of usually body temperature when the enzyme is most active, and after that it eventually starts to degrade. What is Km? The Michaelis constant, and the Michaelis constant measures how much the reaction rate of the the velocity of the enzyme when half of its substrate, when half of its active sites are taken up. Oh, it's concentration at which half the enzyme active reactions half of everything. Induced fit. Substrate binds to enzyme active site and it causes a conformational change to make it fit more into that substrate. Reversible inhibition. We have competitive inhibition, non-competitive inhibition, uncompetitive inhibition, and mixed inhibition. What is reversible inhibition? This is binding of an inhibitor that can be taken off in order to restore an enzyme's normal function. through weak interactions. How does the rate of the reaction relate to the amount? So, as you add more enzymes, you can increase the reaction rate, but if you keep the enzyme constant, there will be a point called saturation where you add so much substrate that all the active sites are taken up, and at that point, Vmax is at the max, and it's called saturation. So there's an optimal pH where enzymes are most active, typically at normal pH, and acidic is really bad, and basic is really bad. What is meant by enzymes? Each enzyme is specific towards a substrate. Generally speaking, cofactors are inorganic and metal ions. 7 key features of enzymes. Lower activation energy, increase the rate of reaction, does not alter equilibrium, constant, are not change or consume, pH temperature sensitive, does not affect delta G, and specific. So specific, lower activation energy, increased rate of reaction, does not alter EQ, delta G, not consume, and sensitive. Okay. Oxygen enzyme that catalyze oxidation reduction reactions typically have dehydrogenase or reductase in their name. Feedback regulation is the controlling of substrates with other products. Allosteric inhibitor. I totally have no idea. Allosteric molecule that inhibits the activity of an enzyme. Oh wait, allosterics. Damn it. Irreversible inhibition. Binding through strong interactions. Typically, the inhibitor will covalently bind to the enzyme to inhibit its function forever. Cofactor or coenzymes. Cofactor or coenzyme are just molecules that proteins require to function normally. Non-protein molecules. What is kcat? Kcat is the catalytic rate for the forward reaction of an enzyme substrate to an enzyme. Equilibrium constant for reaction being catalyzed by an enzyme. Non-competitive inhibition means that the enzyme or the substrate or the the inhibitor will bind to an allosteric site on the enzyme, causing it to change shape and become non-functional. Can overcome by increasing concentration of substrate. How can it be overcome? How does a competitive inhibitor affect Vmax, Km, and line? So competitive inhibition, it will affect Km, so it fixes it to the right. It does not affect Vmax, and on the Lineweaver-Burke plot, it's going to look like a shift on the x-axis to the right, and the v and the y-intercept stays constant. Six classes of enzymes are ligases, lyases, isomerases, hydrolases, oxyreductases, and transferases. Allosteric activators. Molecules bind to allosteric activator enzyme. Okay. How does a non-competitive inhibitor affect Vmax? I have no idea. Non-combined cells are far away from the exit, so substrate binding is not disrupted, means Km is unaffected. High concentration, the non-competitive inhibitor will still occupy its active sites, which means Vmax is lowered. When we have Burke plot for non-competitive, we have a higher y-intercept, no changes. Lineweaver-Burke plot for non-competitive inhibitor of a higher y-intercept with no change in y-x-intercept. So non-competitive inhibitor, no KM. KM is unaffected, and Vmax is lowered. So just be lower. Oh, be higher. Higher. Because Vmax is lowered. Which is inversely proportional. Coenzyme and processor group are just cofactors and coenzymes that act as functional groups to bind to the protein for its function. Hill's coefficient describes cooperativity. If Hill is greater than 1, that indicates that the enzyme is exhibiting positive cooperativity. If Hill's is less than 1, that explains that the enzyme is exhibiting. That tells us that the enzyme is exhibiting negative cooperativity. If Hill's is equal to 1, the enzyme is not exhibiting cooperativity at all. Apoenzymes are enzymes without their cofactors and coenzymes bound. Catalytic efficiency of the enzyme is called kcat. It is catalytic efficiency is kcat over km. Yeah, catalytic efficiency was kcat over km. Uncompetitive inhibitor, no idea. Km is lowered, Vmax is lowered. So it basically locks it in place. Km's lowered, Vm's lowered. So it was a word shift, same slope. Everything's lowered. What is an isomerase? Enzyme that catalyzes the movement of specific bonds and movements around the molecule. Enzymes are very sensitive to the environment. They're sensitive to salinity, pH, and temperature. Uncompetitive inhibition means the enzyme will bind to a uncompetitive. It's not non-competitive. Uncompetitive means this. I think uncompetitive means that it binds to its allosteric site, and it basically renders the protein useless and can be overcome by adding more substrate. Mixed inhibition is a combination of both uncompetitive and competitive. Inhibitor can bind to the enzyme or the ES complex, but with different affinities for each, and Vmax is always lowered. Generally speaking, coenzymes are organic molecules. Allosteric sites are sites away from the enzyme's active site that can be regulated by molecules. A zymogen is an inactive form of an enzyme that must be secreted. Where are two covalent modification made to enzymes to regulatory function? Dephosphorylation and glycosylation. Reversible inhibition is the binding of a inhibitor to an enzyme using weak interaction, so it can be displaced in reverse. Km is the Michaelis constant, and it is the concentration of substrate when the enzyme active site is half full and the velocity of the enzyme is at half Vmax. Cofactors are inorganic and metal ions. Temperature, pH, salinity sensitive. Does not affect equilibrium constant. Does not affect delta G. They're not consumed in the reaction at all. So they show up both sides of the equation. Not consumed. Speed up reactions and stabilize transition by lowering activation energy. Okay. Allosteric inhibitor is something that binds to the allosteric site of the enzyme and inhibits its function. Kcat is the equilibrium constant for the forward reaction of an enzyme catalyzed reaction. Non-competitive inhibition is basically this is not good to put, huh? Non-competitive inhibition is when the inhibitor binds to allosteric somewhere else dangerous too because non-competitive substrate increasing concentration would reverse the inhibition. What is a cofactor or coenzyme? A cofactor or coenzyme is they can be inorganic molecules or organic molecules that serve a functional purpose in an enzyme, or it's required for its functional purpose. I should put non-day proteins, whatever. How does non-competitive inhibitor affect Vmax, Km, and Lineweaver-Burke plot? Non-competitive inhibitors are those that non-competitive inhibitors. I believe those are the ones that uncompetitive, non-competitive at all. So it just binds to the ES complex. So it'll always lower Vmax and always lower Km. So it's going to shift over to the left with the same slope. Oh, nope. Non-competitive. How do I memorize that? Non-competitive binds to allosteric sites. Non-competitive steric site. Allosteric site. Non-competitive. Non-competitive allosteric site. Yeah, I don't know. Non and allosteric. Those two don't mean anything. Non. You can imagine the O as an allosteric site. I can just put that. Imagine the O as being. I'll try that. Non. Imagine the O as an enzyme and the ends are binding to a site away from the O, the allosteric site. Right, and for that we know that Km is unaffected and Vmax is always lowered. That's going to increase. How does uncompetitive inhibitor affect Vmax, Km, and the Lineweaver-Burke plot? So uncompetitive inhibitor, this is not the one with the allosteric site. So they bind to the enzyme substrate complex. They're always going to lower Vmax and Km, so it's going to be a leftward shift of the graph. Uncompetitive inhibition, again, it's not the one with the O. Imagine the O is the enzyme and N is the allosteric site. So this is the one where the inhibitor binds to the enzyme substrate complex, and it simply renders the entire enzyme as being useless. Mixed inhibition is a combination of both uncompetitive and non-competitive inhibition. And mixed inhibition means that the inhibitor can bind either to the allosteric site or the ES complex with different affinity. It will always lower Vmax, but Km is dependent. Two common covalent medication is glycosylation, dephosphorylation, phosphorylation. Non-competitive inhibition, imagine the O is the enzyme and Ns are the substrate or inhibitors. They bind to allosteric sites. So this is when an inhibitor binds to an allosteric site on the enzyme and prevents it from getting products. And this can usually be overcome by just adding more substrates. Non-competitive inhibitor are the ones that have the bind to the allosteric site. So they will always have the same Km because they're not affecting substrate constant, but they also increase or decrease Vmax. So a decrease in Vmax means an increase on the graph. So it's going to have the same x-intercept and an increase in y-intercept. Uncompetitive inhibitors are the one that binds to both the binds to the ES complex, preventing from the release. So this inhibits the enzyme, so decreasing Vmax, and also affects substrate binding. so it decreases Km. So it's a leftward shift of the graph. Okay. That's Biochem Chapter 2. And now let's move on to Bio Chapter 8, which is also another hard one. Actually, I'm tired of bio. Whatever. Go through it. Need water so bad. What a Sunday. Oof. Yeah, I haven't done this one in a while. What do neutrophils do? Neutrophils are responsible for they move to the environment using chemotaxis? No. They detect opsonization. I know that. Chemotaxis. A granulocyte involved in non-specific defense. It's the most populous leukocyte in the blood, and these cells are phagocytic. They follow bacteria using chemotaxis by sensing products released by bacteria. I'll be right back. Give me a second. Okay. Let's change the music real quick. Granulocytes involved in non-specific defense. As well as fellow bacteria using chemotaxis and sensing products have been opsonized. Humoral immunity. Oh man, I totally forgot all of these. Damn it. Humoral immunity. Humoral immunity. Humoral immunity. Oh, I had it. Antibodies dissolving and acting in blood rather than within cells. Humoral immunity is antibodies acting in blood rather than within cells. What are ways in which the gastrointestinal tract can play a role in non-specific? So, gastrointestinal tracts are very acidic, and they basically kill any bacteria, and they also have bacteria inside the tracts that keeps the other pathogens away. Granules contain granules inside the cytoplasms, which contain toxic and toxic chemicals that are used to kill other pathogens. And it's that can be released by exocytosis and effective against pathogens. Okay, I'll say that's hard. I got it. Clonal selection is just the this is where I think it's the B cells can hypermutate, or no. Clonal selection. Is this the one where the antibodies each have 5 different isoforms? So IgA, IgB. And depending on the pathogen, we can select which one. The body can select which one to use. Okay. Only beta cells that combine with the antigen with high affinity survive, providing a mechanism for generating specificity. Only B cells that combine the antigen with high affinity survive, providing a mechanism for generating specificity. Which group of T cells will kill cells that have been invaded by an intracellular pathogen? So the ones that recognize the MHC, I think class 1, or the intracellular. I think it's helper or cytotoxic killer T cells. I didn't know that. I just guessed, so I'm gonna put it as a no. MHC class 1 molecules are typically found all over every single nucleated body of the cell. The main and granulocyte in our body is lymphocytes. Antibody production, immune system modulation, and targeted killing of infected cells late. The main agranulocyte of our body is lymphocytes, which are responsible for antibody production, immune system modulation, and targeted killing of infected cells late, on the other hand. What are the 4 steps that macrophages do in response to an invading bacteria? It first eats the bacteria through endocytosis. and digests the invader using enzymes it has. Then it presents little fragments of the invader to other cells using proteins called MHC, and it releases cytokines or chemical substances that stimulate inflammation or recruit attention. Okay, so cytokines. Okay. It takes so long to initiate antibodies because the B cells have to hypermutate, or is it the antigens? No, the antibodies. No, yeah, the B cells have to hypermutate in order to find the perfect antibody to match the antigen of its antigen binding region to find the best match for its specific antigen. Because B cells undergo hypermutation of its antigen binding region to try and find the best match for a specific antigen. Granules come from hematopoietic stem cells for some reason. What are monocytes? These are cells that are agranulocytes, and they eventually grow on to become macrophages when a pathogen comes in. In tissues, they are phagocytic cells in the bloodstream, and they become macrophages in tissue. B cells mature when in the thalamus, bone marrow. They mature when they leave the bone marrow, but naive because they haven't been exposed to antigen yet. They are mature when they leave the bone marrow, but naive because they haven't been exposed to antigen. The spleen is used for blood storage and beta cell activation. Turns into plasma cells to produce antibodies as part of adaptive immunity. Location of blood storage and activation of beta cells, which turn into plasma cells to produce antibodies. Where do T cells in the thalamus of the thyroid? Small gland from the pericardium, which is a sector. They are a class of adaptive immune cells. They mature in the thymus, a small gland from the pericardium, which is a sac that protects the heart. What is one type of way that pathogens have evolved? So pathogens can now actually inhibit the expression of MHC molecules as a way of defending against the immune system. And the immune system responds by creating something called helper T cells that will detect the decrease in, or natural killer T cells. Natural killer T cells that will detect the decrease in MHC expression and launch apoptosis on those cells. Where do naive B cells hang out in the lymph tissue? They hang out in the lymph node for their particular antigen. Upon exposure, B cells will produce antibodies, while memory B cells. Okay, they hang out in the lymph node for their particular antigen to come along. And upon exposure, the B cell will proliferate and produce plasma cells and memory B cells, and the plasma cell will produce antibodies and memory B cells. Let's say the lymph node, waiting for re-exposure to the same antigen. They hang out in the lymph node for their particular antigen to come along, and upon exposure, the B cell will proliferate and produce plasma cells and memory B cells, and the plasma cell will produce antibodies and memory B cells waiting for exposure to the same antigen. What type of what was it? It was, I thought it was an L. Defensin enzyme is found in our skin. MHC2 is called the exogenous pathway. I shouldn't say why is it called. Describe the MHC class 2 pathway. Exogenous pathway. There we go. Exogenous pathway, these molecules are displayed by antigen-presenting cells such as the macrophages. The macrophages will pick up pathogens from the environment and place them on MHC2. The antigens originate from outside. So macrophages use them. They pick up pathogens from the environment and then place them on MHC2, and then the antigens have to be originated from outside the cell. What is the hormone thymosin used for? Peptide hormone secreted by thymic cells in the thymus, which causes the maturation of T cells. Okay. Peptide hormone. Peptide hormone that is secreted by thymic cells in the thymus, and this hormone will cause the maturation of T cells. Thymosin, peptide hormone that is secreted by thymic cells in the thymus. The hormone will cause the maturation of T cells. Thymosin is a peptide hormone that is secreted by thymic cells in the thymus, causing maturation of T cells. What do T cells do? They are agents of cell-mediated immunity. They're part of the, They coordinate the immune system and directly kill virally infected cells. T cells are agents of cell-mediated immunity. They coordinate the immune system and directly kill virally infected cells. Agents of cell-mediated kill virally infected cells. Pus is a collection of dead neutrophils during infection. There's a complement system. How can it be activated? Complement system. I forgot this one. Consists of the number of proteins in blood that acts as non-specific defense in a bacteria activate through the classical pathway, which requires antibody binding to pathogen, or does not require antibody. Controls in bacteria, destroying them. It's non-specific. A non-specific is a protein that acts in the blood that acts as non-specific defense. I should reword this. Defend against bacteria. A system consisting of proteins in blood that defend against bacteria activate through a classical pathway which requires antibodies or ultramagnet which is not required in the punctures holes in the cell wall, the bacteria destroying them. It's also non-specific. 3 types of T cells. We have natural killer T cells, helper T cells, cytotoxic T cells. Suppressor T cells, killer T cells. Suppressor T cells. What are lymph nodes used for? Provide a place for a immune cell to communicate and mount attack, and beta cells are activated here. Provides a place for immune cells to communicate and mount an attack. Beta cells can be activated here as well. What do basophils and mast cells do? They're crowded granulocytes? Yeah. Basophils and mast cells. Granulocytes involve non-specific defense. They are also involved in allergic reaction. Very rare in the bloodstream, they release large amounts of histamine, increasing vasodilation, blood leakiness in response to allergy. A granulocyte they are involved in allergic responses, and they release large amounts of histamine, which increases vasodilation and blood leakiness in response to allergen. Neutrophils, they are a granulocyte involved in non-specific defenses. They move through chemotaxis or opsonization, which is the marking of a bacteria by a macrophage. I'm going to say no. I'm going to a little bit half wrong. They use by sensing products released by bacteria or have been opsonized, marked with an antibody from bacteria cells. Humoral immunity is antibodies acting in the blood rather than with tissues, rather than within cells. Antibodies acting in the blood rather than within cells. What are interferons? These are proteins that cells make to let other cells know that they're being virally infected. That produced when they have become infected. Proteins this prevents viral replication and dispersion of the cell in nearby cells. Upregulates MHC1 and 2, which increases antigen protection of the immune system. Protein that cells produce when they become infected with the virus prevents viral replication and dispersion of the cell and nearby cells. Upregulates MHC class 1 and class 2, which increases antigen presentation and better detection of this infected cell by the immune system. A protein that cells produce when they have become infected with a virus. This protein prevents viral replication and dispersion of the cell and releases MHC class 1. Protein that cells produce when they become infected with a virus. It's a protein that cells produce when they become infected. The protein prevents viral replication and dispersion of the cell in nearby cells. What is MHC class 1, got 2, blah, blah, blah. Okay. Clone selection is antibodies that only bind to the antigen with high affinity survival data once die out. Which group of T cells will kill cells? Which group of T cells will kill cells that have been invaded by intracellular pathogens? Cytotoxic T cells kill ones that have been intracellular pathogens. The main ingredient says lymphocytes, which is involved in specific defenses, right? Lymphocytes, antibody production, immune system modulation, and targeted killing of cells. Lymphocytes, which are responsible for antibody production, immune system modulation, targeted killing infected cells. So macrophages first engulf the bacteria through endocytosis, and they use enzymes to break down the bacteria, then presents the antigen from the bacteria using the MHC class 1 MHC class 2 pathway, and then that allows it to show the peptide on the macrophage to be detected by immune cells, and also secrete cytokines that recruits other additional immune cells to the area. Why does it take so long to initiate an antibody response? Because the B cells have to hypermutate in order to find the correct antigen. The B cells hypermutate its antigen binding region in order to find the perfect antigen binding region for the particular antigen. Where do granules come from? Granules come from hematopoietic stem cells. Monocytes are agranulocytes, and they are phagocytotic cells in the bloodstream, and they become macrophages in the tissue. B cells mature when they leave the bone marrow, but they're considered naive because they haven't been bound to an antigen yet. The spleen is used for blood storage and activation of B cells. Blood storage, activation of B cells, which turn into plasma cells and eventually form antibodies. T cells mature in the thymus, which is located near the pericardium, which is a sac that surrounds the heart. The body prevents autoimmune reaction by T cells are educated in the thymus. T cells are educated in the thymus. T cells are educated in the thymus. T cells respond to self-antigens are eliminated through negative selection. B cells that respond to antigen. T cells and B cells that respond to self-antigens are eliminated. T cells respond to self-antigen eliminated through negative selection. B cells respond to antigen also eliminated. Each B cell makes only one type of antibody, but we have many B cells. Which type of bonds hold disulfide interactions? Disulfide linkages and non-covalent interaction. What does MHC do? MHC prevents, there's two of them, MHC class 1, class 2, and they prevent peptides of the pathogen on the surface of cells. On the surface of the adaptive immune system. Where do naive B cells? They hang out in the lymph node waiting to be activated by a pathogen, and when that pathogen comes in they'll proliferate into plasma cells and memory B cells. And then the plasma will become an antibody and the other one memory. These will hang out in the lymph node waiting for the antigen to come again. Defense and enzymes on our skin. Humoral immunity is just antibodies dissolving acting in the blood rather than within cells. What the hell? Is there two of them? Now the production of antibodies from B cells very long-term record active. These antibodies are specific to the antigen DMV. Production of antibodies from B cells. MHC class 2 pathway is where we have a macrophage. It binds to the bacteria, brings it in, engulfs it, takes peptides, puts it on MHC class 2, and puts it on the surface of the cell to be recognized by other immune cells of the adaptive immune system, and it's also called the exogenous pathway. Hormone thymosin is a hormone secreted by the thymic cells in the thymus, and that's used to activate the T cells. Binding of an antigen to a B cell causes activation of the cell, resulting in its proliferation and formation of plasma memory cells. Binding of an antigen to an antibody on the surface of mast cells causes degranulation, which releases histamine and causes an inflammatory response. Binding of an antigen to antibodies on the surface T cells are cell agents of cell-mediated immunity, modulate the immune system, and kill virally infected cells. Passive immunity. This is where you're injecting the antibody into the blood. Complement system is proteins that act within the blood against bacteria, non-specifically activated by the classical pathway with the antibody or the non-classical pathway without the antibody. And they're essentially, proteins will puncture hole in the bacteria to cause the death of those bacteria. Three types of T cells. We have the suppressor T cells, helper T cells, and cytotoxic killer T cells. Lymph nodes are used for area for the immune system to coordinate an immune response, where cells can hang out in, and the activation of B cells happen in the lymph node. MHC class 1 pathway is called the endogenous pathway, and it's used to, we have the intracellular pathogen gets attached to MHC class 1 molecules and then put onto the surface of the cell. Why does the lymphatic system connect to the cardiovascular system? At the, it was called at the posterior duct. Thoracic duct in the posterior chest. Via the thoracic duct in the posterior chest. Basophils and mast cells are granulocytes, and they're non-specific defenses against bacteria, so they respond to against allergens, and they release lots of histamine, which causes vasodilation, increased blood leakiness, and an inflammatory response. Hematopoiesis is the formation of blood cells from the bone marrow. Poiesis is bone marrow producing all of our leukocytes that participate in the immune system. Bone marrow producing all the leukocytes that participate in the immune system. What type of immune tissue surrounds the digestive system aside for potential? Oh, I totally forgot there's a gout. Yeah. The gut-associated lymphoid tissue, which includes the tonsils and the adenoids in the head, Peyer's patches in the small intestines, and the lymphoid aggregates in the appendix. The gut-associated lymphoid tissue. Which includes the tonsils, the adenoids in the head, Peyer's patches in the small intestines, and lymphoid aggregates in the appendix. Plasma cells, memory B cells derived from B cells, and memory B cells wait in the lymph node. Plasma cells go on to form antibodies for the antigen. Eosinophils are involved in well, first of all, it's an granulocyte, and it's involved in non-specific things in bacteria, using allergen and pathogenic responses, or infections from bugs, and releases histamine, vasodilation, blood leakiness. parasitic infection leads to autoimmune activation the blood into the tissue. Interferons are proteins that cells make when they become virally infected. This prevents viral replication and prevents the spreading of this virus to other cells. Interferons, and also upregulates MHC class 1, class 2 molecules. Neutrophils, they're granulocytes involve non-specific defenses. They follow bacteria through chemotaxis using products secreted by bacteria, or following bacteria through opsonization, which has been marked by an antibody from a B cell. Humoral immunity is either antibodies acting in the blood rather than proteins, or B cells, the use of B cells to turn into antibodies used for defense. Which group of T cells will kill cells that have been invaded by intracellular pathogens? Intracellular pathogens, MHC class 1, uses cytotoxic T cells. What are some professional antigen-presenting cells? Macrophages, dendritic cells, B cells, and certain activated epithelial cells. Macrophages, dendritic cells. Macrophages, dendritic cells in the skin, some B cells, and certain activated epithelial cells. Self-antigens, these are antigens that are found within all cells of our body that are recognized by the immune system as not being foreign. Macrophages and dendritic cells. They contain a T pattern recognition receptor designed to recognize a category of the invader. Production of appropriate immune cells. Contain special receptors called pattern recognition receptors, which allows them to recognize a category of the invader, bacteria, virus, or fungus, and allows them to produce the appropriate cytokine to recruit the appropriate immune cells. Which cells govern the humoral response? And so similar, cell mediated response is governed by the T cells, humoral response is governed by the B cells. What are some examples of granulocyte cells? Basophils, eosinophils, and neutrophils. Easy. What is the adaptive immune system? B cells and T cells. Describes its target defenses of target specific induction to faster second. Defenses that target a specific pathogen. Defenses that target a specific pathogen, so which act can maintain a memory of the infection to fast track subsequent infections. What is the lymphatic system involved in? Transport of lipids, I know that. Equalization of fluid distribution, transportation of fat and fat-soluble compounds, and chylomicrons providing site for immune response. Mounting immune attack, fluid distribution, and transportation of fat in chylomicrons. The main agranules in our body is the lymphocyte, and the lymphocytes involved in antibody production, immune system modulation, and targeted killing of cells. How does the body prevent autoimmune reactions? We have the T cells being educated in the thymus. So T cells and B cells that are found to be self-reactive with self-antigens are destroyed through something called negative selection. What type of bonds hold the light? Disulfide languages and non-covalent interactions hold the light and heavy chains of the antibody together. The MHC molecule will bring antigens and present it to the antigen-presenting cells, typically macrophages, dendritic cells, some epithelial cells, and some B cells, and that causes it to be recognized by cells in the adaptive immune system. Active immunity. This is inserting a weaker strain of a foreign pathogen, so your body can fight it off. This is the basis of the vaccine. Now, negative selection of T cells is destroying T cells that are self-reactive to self-antigen. I don't know what positive selection is. I see. Humoral immunity. Any B cells acting to form antibodies acting in the blood rather than within cells. In adaptive immunity, what do B cells turn into? Plasma cells and memory B cells. Memory B cells hang out in the lymph node waiting for subsequent reaction. Plasma cells will go on to form antibodies specific to the antigen. Helper T cells, I don't know what they respond to. They coordinate the immune system by secreting lymphokine chemicals, which recruit other immune cells and increase their activity. They respond to antigen on class 2 molecules. So the exogenous pathway. They coordinate the immune system by secreting lymphokine chemicals, which recruit other immune cells and increase their activity. They respond to MHC2. So helper T cells bind to MHC2. They coordinate the immune response by secreting lymphokine chemicals, which respond to MHC class 2 molecules. Describe this as an intracellular okay, I just know what I'm going to memorize this. Yeah, I don't think I'm going to memorize. Virally produces interferons. Infected cell also presents intracellular viral proteins in conjunction with MHC1 because it's intracellular. Cell toxic T cells will recognize MHC1 in the antigen complex as foreign because it recognizes MHC1 and induces apoptosis. Downward natural codes will come in when it's cleared. MHC will generate and remain. When antigen binds to B cell, it causes proliferation into plasma cells and antibodies. If they bind to surface of mast cells, it will cause degranulation, secretion of granule content, and also secretes cytokines to recruit other cells, histamine, and causes an inflammatory response. Oof, I don't remember. They produce a non-specific bacterial enzyme called lysozyme, which is secreted in tears and saliva. They produce a non-specific bacterial enzyme called lysozyme, which is secreted in tears and saliva. What are two types of leukocytes? Agranulocytes and granulocytes. Leukocytes, agranulocytes and granulocytes. What are two distinct divisions of the immune system? We have the adaptive immune system and the innate immune system. What is the innate immune system? I don't know. What is another name for innate immunity? Non-specific immune response. What are memory T cells? Memory T cells are so much memory they wait till next exposure to the same antigen to carry out a faster response. Nice. Similar to memory B cells, they wait until next exposure to the same antigen when activate can carry out a faster response. Okay. MHC class 1 pathway is the intracellular pathway or endogenous pathways, where if you have a pathogen inside the cell, you can load it onto the MHC class 1 molecule to be presented onto the surface of the cell to be recognized by something like a natural or a cell toxic killer T cells. Lymphatic system connects to the cardiovascular system at the thoracic duct in the posterior chest, where 3 protocols and antibodies will follow: opsonization, agglutination, and neutralization. What's on opsonization, agglutination, neutralization? Antibodies can block the ability of pathogens to invade tissue. Blocking them to invade our tissue. Agglutination is forming a complex which would be phagocytosized, and opsonization is when it binds to, it marks it for phagocytosis. Okay, I'll just redo it again. Formation of all the leukocytes for the immune system. What type of the gut-associated lymphoid tissue, and it's associated with the thyroid and Peyer's passage in the small intestines. Peyer's passage in the small intestine, lymphoid aggregates in the appendix, and the thyroid in the head. I forgot something. Tonsils and adenoids in the head. Peyer's passage in the small intestine, and lymphoid aggregates in the appendix. Okay. Lymphatic system. Circulatory system that consists of one-way vessels with intermittent lymph nodes. Circulatory system that consists of one-way vessels with intermittent. Circulatory one-way vessels with lymph nodes, basically. Eosinophils are involved in parasitic infections and allergic reactions. They are granulocytes and nonspecific, and they release a shit ton of histamine, which causes vasodilation and blood leakiness to allow for immune cells to mobilize quicker into the area of the infection. In bacterial infection, so you're going to use the granulocytes. What is isotype switching? Isotype switching, antibodies have different isotypes, and we can use specific isotypes of antibodies depending on the signal from the cytokine. They produce when specific cytokines. What are macrophages? They come from B cells, and they are activated in the tissue when a pathogen comes in. No, they're activated when they go into the tissue, basically. Oh, activated when bacterial invader enters a specific tissue. So we have macrophages for sure, dendritic cells, some epithelial cells, and some B cells. Cytotoxic T cells respond to MHC class 1. I don't remember how they kill. They inject toxic chemicals. They kill infected cells by injecting toxic chemicals, respond to MHC 1. Macrophages and dendritic cells have TPPR, which is recognition pattern receptor. Pattern recognition receptor, PRR, which recognizes a type of pathogen such as bacteria or fungus or virus, or bacteria, fungus, etc. And basically that allows them to secrete certain cytokines that recruit specific antibodies to come in. Oh, yeah, virus. Humoral response is governed by the B cells. T cell immune response is governed by the T cells. Primary response, secondary response is faster. Primary response is the first time you have a new infection. This is where the B cells have to do all that plasma cell antigen switching, all that isoform switching, all that. Secondary response uses the memory B and T cells to launch the attack. Adaptive immune system. This is where we can produce antibodies that are specific towards one specific pathogen, but slower to act. Lymphatic system is involved in equalization of fluid distribution, transports of fats through chylomicrons, and provides a location for the immune system to mount an attack. The innate immune system is another word for non-specific immune system. Defenses that are always active against infection. Suppressor and regulatory T cells. They differentiate from helper T cells, and these cells tone down the immune response. Once infection begins. They also turn off self-reactive lymphocytes to prevent autoimmune disease in a process called self-tolerance. They differentiate from helper T cells, and these cells tone down the immune response. Process called self-tolerance. Okay. Positive selection is used allowing the T cells to mature when they can react with foreign pathogens, and negative selection is killing T cells that are reactive with self-antigens. Helper T cells are helper T cells are a group of T cells that they secrete, I think it was cytokines that also recruit other, or is it lymphokines? I think cytokines that recruit other immune cells to the area. Respond to MHC class 2. Lymphokine chemicals to recruit other cells. Lymphokines, okay. what do the mucous membrane? They produce something called lysozyme, which is found in our saliva and tears. It's a non-specific bacterial enzyme. Another name for innate immunity is non-specific defenses. Memory T cells are similar to B cells where they can wait for subsequent reactions to launch a faster attack. B cells cause them to proliferate to plasma cells, memory B cells. Surface of mast cells causes degranulation and secretion of cytokines. Oh no, causes so when antigen binds to the surface of mast cell, it causes them to degranulate, so release of granule content through exocytosis, and causes a release of histamine, which causes an inflammatory response and vasodilation, leaky blood vessels, etc. Opsonization, which is a marking of an antigen by an antibody to recruit other inflammatory cells or immune cells for phagocytosis. Agglutination, which is where you form the antigen into an insoluble complex to be phagocytosized. And there's neutralization, where you prevent the infected cell from spreading to other cells. Lymphatic system, one circulatory system consisting of one-way blood vessels and lymph nodes. Isotype switching is the idea that our body has 5 different isoforms of antibodies: IgA, IgB, IgE, etc. And the body can produce specific isoforms of antibodies depending on what certain cytokine signal is received. We have the gut-associated lymphoid tissue, or gout, and it's responsible for the tonsil and adenoids in the head. It's associated with the tonsil and adenoids in the head, pairs pathogens in the small intestines, and lymphoid aggregates in the small appendix. Macrophages come from monocytes, and they're activated when a pathogen invades the specific tissue they reside in. Cytotoxic T cells respond to MHC class 2, and they inject a toxic chemical into the pathogen to kill it. What is the innate immune system? Non-specific defenses against bacteria that are always on. Suppressor, they're derived from helper T cells, and when the immune response is over, they will cause they tone down the immune response and turn off self-reactive lymphocytes. Lymphocytes to prevent autoimmune disease in a process called self-tolerance. Helper T cells, they secrete lymphokine chemicals to recruit other additional immune cells to an immune response, and respond to MHC class 1. Class 2. Mucous membrane, the eye and oral cavity, produces a non-specific bacterial enzyme known as lysozyme in our saliva and tears. Suppressor regulatory T cells differentiate from helper T cells, and they respond to, or they tone down the immune response when immune response is finished, and they also kill lymphocytes that are still self-reactive in a process called self-tolerance. Helper T cells, they secrete lymphokine chemicals to recruit other additional immune cells to the area, and they respond to MHC class 2 molecules, or the extracellular pathway. MHC class 2 molecules. MHC 1 is intracellular. And that does it.